Hello children, today our topic is speed in time, motion and time chapter. Children, what is speed? The distance covered by a moving object in unit time is known as its speed. You have seen two things I have told. The distance covered. So what is required in the speed? Distance. The distance covered by a moving object in unit time. Second thing is time we must know. Okay, is known as speed. What is the as standard SI unit for speed? Meter per second. As we know, SI unit for distance is meter and for time is second. So SI unit for speed is meter per second. Okay, if we need to find out the speed, what two things we require to know? First, as I told you, distance, and second, time. Okay, like I am giving you the example, the distance between Delhi and Kanpur is around 500 kilometers. Suppose 400 to 500, but I am taking 500. Okay, a bus takes 10 hours. A bus takes 10 hours to travel from Delhi to Kanpur. At what speed does it travel? So we need to take out speed. We know the formula of speed is distance upon time. Distance is what? 500 kilometers. It is in kilometer and hours. An hour, 10 hours it takes 10 hours to cover this distance. So what is the speed? 50 kilometer per hour. We can change the unit from kilometer to hour. Like we convert kilometer into hour. Like 1 kilometer is equal to 1000 meters and 1 hour is equal to 3600 seconds. So meter per kilometer per hour, if we want to change into meter per second, we multiply by this and we can reduce it. It would be 5 upon 80. So if we need to convert like this kilometer per hour into meter per second, we multiply this number by 5 upon 80. And our answer would be in meter per second. And opposite, if the thing is given in meter per second and we have to convert it into kilometer per hour, then we just make it upside down, 18 upon 5. And we can convert meter per second into kilometer per hour. Now next our topic is distance time graph for uniform motion. Distance time graph. Okay, first we are going to discuss for uniform motion. Uniform motion. Here children, two things we must know, distance and time. Like here I am writing down time and distance. Suppose time, here I am writing time and this is distance. I am taking time in minutes and distance in kilometer. Okay, like any vehicle starts at 9 a.m. When it is starting, that time distance is like starting point is always 0. At 9:05, it has covered 5 kilometer. 9:10, 10 kilometers. 9:15, 15 kilometer. 9:20, 20 kilometers. And 9:25, 30 kilometers. So these two things we have Now we have to draw a graph. So what we will do, we will draw the vertical line, this is our y-axis. Horizontal line, this is our x-axis. Now children, the most important thing, we will take up the scale. Very important to take the scale. First we will, and this side is time, we will take the horizontal side time and vertical side distance. Okay, now we are going to write down this. Time we are seeing the time interval like 0, 5, 10. So it is like table of 5. So scale in x-axis, one box is equal to almost 1 centimeter. So here we are taking 1 centimeter is equal to 5 minutes. And this side you see also the difference is of 5. So in y-axis also 1 centimeter is equal to 5 kilometer. Okay. Now we are going to draw 0 for the time this side, 9 a.m. then 9:05, 9:10, 9:15, 9:20 and 9:25. Same way, distance in kilometer. We are here, you write down minutes. Distance 0, 5, 10, 15, 20, 25. So children, at 9 a.m. the vehicle is started. At 9:05 it has reached 5 kilometer. 9:10 it has reached to 10 kilometer, covered 10 kilometer. At 9:15 covered 15 kilometer. 20 covered 20 kilometers. And at 9:25 it has covered 25. Now we are going to join these points, we will get the straight line. When we get this straight line, it means the vehicle is running at uniform or moving at uniform motion or uniform speed. So our body is said to be in uniform motion if it travels in a straight line like you are seeing and covers equal distance in equal intervals of time. Now we are coming to the other graph, like distance time graph for non-uniform motion. Here we have taken the same timings, but we are seeing the car is covering different like distance in different time. Like in 5 minutes it has covered 2 kilometer. In another 5 that it has covered 5 kilometer. Okay, so these are the distance. Now the time is same here as we are seeing, but distance we see the lowest is 0 and the highest is 10. So we are going to divide it accordingly. Okay, like we are this is our 2, 10, 12 suppose, or we say 15. Okay, now lowest is 0 and uppermost is 15. So we are going to take 2, like table of 2 we will take like 1 centimeter is equal to 2 kilometers, or we can take 4 kilometers also, it is easy for us. Now 2, 4, 6, 8, 10, 12, 12. Okay, this we are going to take as 12. Now, at 9 am it is at 0. Fine. 9:05 it is at 2. 9:10 it is at 5. Between 4 and 6 the 5 is there. And 9:15 it is at 6. And 9:20, 10. And 9:25 at 12. So we are seeing first like this. Here we are not getting a straight line. So when we get this such graph, we will say that the vehicle is moving with the non-uniform motion. So when what do we say? A body is said to be in non-uniform motion if the speed or distance of the body does not remain constant. Okay, children? And few more things I would like to tell you. Suppose the graph is like this. If it is like this is time, this is distance. Okay, we have the graph like this, means at particular time is increasing, time is passing, but the vehicle is at same distance, means vehicle is at rest. Okay, children? So when it is parallel to this, that time we say vehicle is rest. Sometime we see the graph like this. What happened this time? The distance is increasing but the time is remained same. So this is not possible. We say it is impossible. When we get such like parallel to distance, we say this is impossible. Okay. So that's all, children. Thank you.